Equations of lines. Basically what we've done so far with lines is I've given you the equation of a line, and I've asked you to give me information. I've asked you to give me the slope, give me the intercept, draw me a graph. What we're going to do in this section is we're going to go backward. In this section, I'm going to give you information about the graph, and you're going to give me the equation. There are two common formulas that we use for the equation. One of them we've already looked at, y equals mx plus b. And together with that formula, you're generally going to use this formula, m equals y2 minus y1 over x2 minus x1. We've had those two already. The third formula that we use quite often looks like this. It's y minus y1 equals m times x minus x1. And this is called the point slope formula. So, whenever you see the directions, find the equation of the line, you're going to use one of these two formulas. The truth is, for any given problem, you can use either of the two formulas, whichever one you like. But I'm going to show you that sometimes one might be a little better than the other. But I'll show you how to use them both. Before we do that, let me talk a little bit about that second formula and where it comes from. So the second formula is really a rearrangement of this formula. Ooh, boy. There's a huge mistake right there. In your slope formula, x's never go on top. That's a very common mistake people make. I just made it myself. Y's always go on top. Hard to talk and write sometimes. Alright, x2 minus x1. Okay, so what I'm going to do with this equation is I'm going to take this equation and I'm going to multiply the whole thing by x2 minus x1. When I do that, I get m times x2 minus x1 equals y2 minus y1. And right away you should see that that looks very like that formula we had. So remember, in the slope formula, x1 and x2 is any specific point on the line. We're going to let x2, y2 now be any point at all on the line, not a specific one. So instead of writing x2, I'm just going to write x. And instead of y2, I'm just going to write y. And so just switching sides, oops, you can see that we get the formula I had written on the previous page. Y minus y1 is m times x minus x1. So the point slope formula is really just a rearrangement of the slope formula that you know and love. Okay, so let me show you the kind of problems you're going to see in this section. I might say, find the equation of the line so this is going to be the directions for the next several problems. Problem 1. Slope equals 4, y-intercept equals 0, negative 3. Alright, well this is a very, very simple one. You should recognize that I gave you the slope, I gave you the y-intercept, so you should use slope-intercept formula, y equals mx plus b. So this one, really no work to do, y equals 4x minus 3. That one's as easy as they come pretty much. Alright, so same directions, find the equation of the line, problem 2, through 0, 2 and 5, negative 1. Okay, so this time I've given you 2 points. Now it turns out one of the points I've given you is very important. This one. That one you should recognize. That one happens to be the y-intercept. You know it's the y-intercept because it's 0, 2. Anytime you have 0, something, you've been given the y-intercept. I don't know the slope, but that's alright. I know how to find the slope. M equals y2 minus y1 over x2 minus x1. So that's negative 1 minus 2 over 5 minus 0. That's negative 3/5. Alright, so now I have the slope, I have the intercept. Once again, I would go ahead and I would use y equals mx plus b. Y equals, my slope is negative 3/5 x plus b is 2. Alright, so you see how that one was slightly more difficult than the first one. Slightly more difficult because I didn't give you the slope right away. You had to go figure it out. Alright, question 3. Through 2, 8 and negative 3, negative 4. Alright, this time once again, immediately you should recognize that I did not give you the slope. If you're dealing with a line, anytime you're dealing with a line, you always have to have the slope. Not a choice. So m equals y2 minus y1 over x2 minus x1, negative 4 minus 8 over negative 3 minus 2. That's negative 12 over negative 5. That's 12 over 5. Okay, now what you need to recognize is this time I did not give you the y-intercept. We see that we do not have the y-intercept because we don't have x equals 0 in either of our 2 points. Now this is my personal opinion. If I don't have the y-intercept, I am now going to use y minus y1 equals m times x minus x1. This is my choice. I'm going to redo this problem in a minute using y equals mx plus b to show you can do it either way. This is what I like. Okay, so y minus, I pick one of the two y numbers. It really doesn't matter which one. I guess I like 8 equals m is 12/5 times x minus 2. And that's a perfectly acceptable answer. Sometimes students don't like that answer very much. It's not simplified. It's not in y equals mx plus b form, but that's okay. The other complaint I hear is students tell me, well, I can't graph it on my calculator because y isn't all by itself. My answer to that is add the 8 to both sides, but don't simplify. Type it into your calculator exactly like that. Your calculator will graph it. It won't care if it's simplified or not. Okay, so as far as I'm concerned, that is a perfectly acceptable answer. The directions were find the equation of the line. They didn't say simplify it. They didn't say write it in mx plus b form. Okay? All right, but let's do this problem over again. So I got to remember 2, 8, and 3, negative 3, negative 4. So we had 2, 8, and negative 3, negative 4. And I'm going to skip right ahead here. We found the slope to be 12/5. And I just want to show you that on this problem you can use y equals mx plus b form. Some students like to limit the number of formulas they have, so they just want to use that one. And here's what you would do. You would write y equals m is 12/5 x plus b. And what we need to do is figure out the b. To figure out the b, we take one of the 2 points. It doesn't matter which one. I personally like this one. And we plug it in. So instead of writing y, I'm going to write 8 equals 12/5. And instead of writing x, I'm going to write 2 plus b. And then we have to get the b all by itself. So 8 equals, think of 2 as being 2 over 1, 24/5 plus b. So b is 8 minus 24/5. That's 8 times 5 is 40/5 minus 24/5. That's 16/5. So my final answer would be y equals 12/5 x plus 16/5. Alright, so it works. It's not terrible, but you do have to mess around with the fractions. And that's something that a lot of students don't like. A lot of students don't like messing around with the fractions, so they try to avoid it. Your choice, okay? You can do it either way. And by the way, it doesn't matter which points you pick. I could have used these 2 points. That 1 point, I mean, that x and y value, plugged it in, I would have gotten exactly 16/5 again. And the same with doing it the other way. Had I done it the other way, I would have gotten exactly the same answer if I'd used -3, -4. All right, 2 more examples. I think, where did I leave off? I think this is number 4. Through 2, -1, parallel to y equals 2/3 x minus 5. All right, well, for this one, you need to know a little something about parallel lines. What you should know about parallel lines is they never cross. And the reason they never cross is they go exactly the same direction and they have exactly the same steepness. Well, that's a fancy way of saying they have exactly the same slope. So what I'm telling you is I want a line that has slope of 2/3. So I'm giving you the slope is 2/3, and I give you a point. So once again, my personal preference here, I would use y minus y1 equals m times x minus x1, because this point given back up here is not a y-intercept. Y minus -1, that's y plus 1, equals 2/3 times x minus 2. And again, as far as I'm concerned, perfect answer. No reason to simplify it. Leave it just like that. Alright, last example, number 5. Through -3, 1, perpendicular to y equals 3/5 x plus 3/8. There's a nice equation. All right, well, you need to know something about perpendicular lines. I'm sure what you know about perpendicular lines is they meet at right angles. What you might not know is the property of their slopes. For this line that I gave you, there's your slope, m equals 3/5. For the perpendicular line, the slope will be what's known as the negative reciprocal. Negative reciprocal is fancy words. Reciprocal means flip it over. So instead of 3/5, I write 5/3. And negative means put a negative in front of it. So since this slope is positive, this slope is going to be negative. Had the orange slope started off as negative, then the purple one would get another negative sign, which would make it positive. All right, well, once we have that, we're pretty much done. Y minus y1 is m times x minus x1. Y minus 3, y minus 1 equals -5/3. I don't like my 5 very much there. -5/3 times x minus -3, that's x plus 3. Alright, the last thing you have in this section is what's called modeling. And actually we've been doing modeling all along. Modeling is given data, finding equations that match them. In this section, what's going to happen is you're going to be given large sets of data. You might look at your homework at the end of this section. And what you're going to do with this large set of data is you're going to graph it, and then from the large set, you're going to find the equation that best fits the data. There are ways to do that by hand, but we're not going to do that by hand in this course. What we're going to do is we're going to use a graphing calculator. So what you need to do is you need to go to the graphing calculator help area. On MyLab, and look for the video on regressions. I have a complete separate video for that I use. Okay, so that's in a different area. You're going to have to look that up. There's a folder for graphing calculator help, and in that you'll find a video called regressions. Go watch that video, and that video will show you how to use your calculator in order to find regressions.